So who's excited about testing? Oh, excited? Yeah. OK, how many of you are testing your apps already? Is there anyone who is not testing their apps? I don't believe you. Unless your apps are not working. So yeah, testing, Android testing. There's been a lot happening during the past 2 years in Android testing. We've been getting better and better at this. There's now great support in Android Studio and Gradle to run your tests. There is the Android testing support library. It's an unbundled library. It's unbundled from the framework. You can update it with the support library. It's always fresh. That's a good thing. And one of the pieces of this is Espresso, our UI testing framework, which you probably all know about since you're all testing your apps. But that's the part that we're going to concentrate on today. So yeah, Espresso, just as a quick recap, quick intro for maybe those of you who are listening on the live stream who are not Espresso experts yet. So this is a basic, I want to discuss the basic Espresso test flow. So this is an app we built a couple of months ago for a code lab, for an Android testing code lab. It's a simple simple note-taking app where you can just, you have a list of notes, you can add a note, add some text, save it. That's pretty much it. The thing is, it's a nice way, this app is a nice way of like looking at tests and explaining them. Because UI tests seem like a very human way to test your apps, right? You get the interface, you look at it as if you were looking at your phone. And what do? You first identify some view you want to perform actions on. So in this case, I want to add a new note. So I click the fab, right? And then on the second screen, I want to type some text in, save the note, and then finally verify if the note was added. It's a simple thing, very human way to test an app. And how does it look in code? So Espresso has this simple, really fluent API that lets you express these kinds of tests in an easy way in code. So let's do that quick run through. So first of all, like I said, we need to find a view. And here we are looking for a view with the ID add note. It's the fab. When Espresso finds the view, I want to perform an action on it. I want to click on it. And then on the second screen, again, I'm finding views, in this case, the input fields, and I'm performing another action. It's type text. So I'm typing text into them, again, clicking on the fab to save the note. And here in this the last line of code, you see things are a little bit different. I don't want to do any more actions. I want to verify the result of my tests. So instead of performing an action, I'm actually doing a check. I'm trying to match if the note that I added, if the text that I added with the note is actually displayed on the screen. So that's the basic Espresso test, right? And one nice thing about Espresso is you might notice that apart from those basic building blocks, these on-view calls, these view matchers and view actions and assertions at the end, there's nothing really in between. And that's the magic of Espresso. This is the whole point of using this framework. Espresso, notice how in the previous, in the test that I displayed, we went through another activity and back. We went through 3 different screens. We performed typing. We had to wait for the screens to change and finally to display the final result. But there was no code in between to wait for those events. And that's Espresso. But when people come from different backgrounds, from different testing frameworks maybe, and they try to use Espresso for their apps, I see a lot of questions on Stack Overflow and answers that kind of try to work against that API. And so let's look at like something that that I've seen in answers on Stack Overflow that's not entirely correct. So instead of working with Espresso and using the constructs that I just discussed, like view matchers, people usually ask a question: how do I get the view? How do I get at that view object to like do things to it, to change properties and verify things? Well, you really shouldn't. This is like a very obscure API. This is not meant for you to use. This will just not work. The other thing that is a little bit more dangerous is like getting the activity and like finding stuff in the view hierarchy. This line of code would actually work, but it's not really what you want to do. I mean, it will work as in it will not throw an exception. But again, this is working against Espresso. And one question for you. This is something I've seen. How many people will think this test will actually pass? No? Well, it will because it doesn't do anything. It just, on view, doesn't run any real Espresso actions. It just returns a view interaction object, which you can act upon next and enqueue actions or do assertions. This doesn't even look for the view in the hierarchy. So going back at a proper Espresso test, like I said, this just returns a view interaction object. And only when you actually act on that, this is where the Espresso magic starts. And so in this first part of this presentation, I just want to talk to you a little bit about internals so that you have the knowledge that will help you when building your tests and fighting all the different scenarios and different ways that your tests can fail. So let's look at the view interaction class. This is source code from Espresso. It's open source. You can go look it up. You can open it yourselves. You can dig into it. I really encourage you to do it. It's not that big. And it can give you a better understanding of what happens under the hood. So when I perform an action on the view interaction object, this method doPerform is called. And the first very important thing that happens is it starts running everything that it does on the main thread. So the test method that you write, it's actually on a different thread. If we want to work with views, work with the view hierarchy, we have to switch to the main thread first. Then, this is a very, very important thing. UI controller is the most important part of Espresso, I would say. This is an internal class in Espresso. I mean, a class in Espresso that has this method called loop main thread until idle. And this is where all the magic happens that I mentioned before. This is the place where where Espresso waits for your app to be idle. And I will discuss in a sec what it actually means for your app to be idle. And only then, only after Espresso finds that it can actually run your actions safely when the app is not doing anything, will it actually kick off, traversing the view hierarchy, finding the view and matching it against your matcher. Only then. And then when it finds the view, of course, it performs the action and passes in the UI controller. So if you're writing any custom actions, you can use it again instead of trying to do things without Espresso. So UI controller, loop main thread until idle, a long name. But so what it does, it first sets up conditions. It looks at async tasks in your app. It also looks at async tasks from the support library, which use a different thread pool, so it needs to look at both of those. Then it looks at all the idling resources, which is a custom mechanism to tell Espresso that your app is not idle, which I will discuss in a sec. It sets up all these conditions, waiting for all these things to be idle, and then runs another method, which just loops and waits until these conditions are met. And what's important in the end, it also looks, and the main looper, like a looper is something associated with your thread that has a message queue. So it basically looks in the message queue if there are any events that are still pending, still preventing Espresso to run safely. And there's one common misconception about this. So if I have a handler that's attached to the main thread, so I'm posting to the main looper, right? If I post a message, post a runnable that's delayed 500 milliseconds, what do you think? Is the app idle now after I run this line of code, or not? Who thinks the app is idle? It's not, and you're right. You must be real advanced Espresso experts since you came to this talk. So when the queue is empty, so this is, again, part of Espresso. This is part of a class that looks at the message queue and determines if it's safe to run. So the first condition is pretty straightforward. If the queue is empty, if there are no events on the main thread that are waiting to be executed, then, of course, we can run. But then there's this other part of the condition. And what is this task due long? Basically, it's a task that's a long time in the future. And if you look at another piece of code that looks at the queue state, there's actually a constant that we came up with when working with Espresso for a long time and testing different scenarios. And basically, we found that if we look only at messages in the message queue that are up to 15 milliseconds in the future, then this will work for many, many scenarios. So just one thing to be aware of, because that's a common misconception I've seen online. So yeah, if I post something really far in the future, Espresso can run. And circling back to idling resource. So idling resource is a pretty simple but powerful concept that you can use if you have long-running operations on different threads in your app, on threads that are not using async task or async task compat, because Espresso can synchronize on those. But if you have some kind of network operation or some kind of long computation, something you have to wait for until your app is actually considered idle, you just implement this interface. And again, it looks pretty simple, but people do, lots of developers, especially in the beginning, and everyone's a beginner at some point, of course, people actually do a lot of computation or figuring out if the app is idle in the isIdle method. And I really encourage you to make it as simple as possible. This should be just returning a Boolean flag if your app is idle or not. Don't call onTransitionIdle in the isIdle method. Instead, when your app actually becomes idle, when your network request finishes, your computation finishes, then remember to call onTransitionToIdle on the callback that Espresso supplied to you, because that's really telling Espresso, I'm going to be idle now, check my state, and maybe Espresso can run now. And I just want to mention another powerful method on the UI controller. If you're ever writing any custom interaction, any custom actions, whenever you feel like you want to use thread sleep, because you know that sometimes need to pass between an event that you want to happen, don't use thread sleep, please. Instead, use the construct we give you in Espresso. Use this method. It sets up a condition. It waits until the time passes, and then, again, with loop until, you get all the same guarantees about the message queue, about the app being idle. So please use those things if you're doing more advanced stuff. And moving on, in the second part, I just want to talk to you about tips and various pieces of advice that I gathered from internal teams at Google working with Espresso. Hopefully, it'll help make your tests better, less flaky, more maintainable. So I'm going to go one by one through them. Yeah, I mean, do you care about your code structure, your app's architecture, your good quality overall for your app? Probably yes. Well, then why shouldn't you care about the same for your tests? Let me just show a very, very simple example if you're still not convinced. So with Espresso, sometimes you need to code pretty close to the implementation, right? For example, if you use onData to look for views in your adapter views in a list view, the simplest example of this, you have a list view backed by an adapter backed by like map items, and so you write this line of code, your test passes, and then you need to use it in another test, and so on. So you copy-paste it everywhere. And then imagine you change the adapter, you change the data that's backing your list view. You're starting to use a cursor or whatever else. And suddenly, you have to go and change it in every test in your code. Pretty daunting. So instead, just try to abstract away any more complicated matchers, any more complicated pieces of code. Try to, again, this is very simple. You can write your own robots or more sophisticated ways to abstract away working with screens in Espresso. But then you just need to change one place and your test will pass again. Then one thing I want to stress throughout this presentation, please use the available APIs and classes that we give you in Espresso. Use the available matchers. We provide a lot of matchers for pretty much every view that's in the framework, for most properties that are in the framework. And if something is missing, then maybe we omitted it, maybe it should be there. And it will be nice if you find this kind of situation to please file a bug with us. But on the other hand, we can't know everything about the custom views you make. So definitely there are moments when you would like to write your own matchers. And another instance of that is if you find that you are combining lots and lots of matchers for your actions, maybe it's nice to just, again, abstract away this complexity and write a custom matcher, a compound matcher that does that. I just want to point out that, again, there are classes that will help you with that. So for the simplest matchers, you want to just extend the type-safe matcher that will work only on views. You don't have to do casting and things like that. And if you want to filter out, this is very similar, but if you want to filter out just certain types of views, just subclasses of certain views, use the bounded matcher. Again, you will not have to do the filtering. You will not have to do casting in matches safely. You will just get the views of the type that you care about. Again, reuse. We provide counting idling resource. Just use it if you can, if you don't need to write your own. Many people, try again, like I said, writing custom idling resources. They get tangled up in those, where should I call which method, when am I idle, and so on. Counting idling resource has a very, very small API. It's basically you call increment and decrement. So you call increment before you start a long-running operation. And you call decrement when it's ended. And whenever the counter is at 0, so that means no long-running operations are running, and Espresso can consider it idle. So please use it if you don't have a better reason to write your own. And on the topic of idling resources, sometimes, for example, when you use one counting idling resource for everything, you might find that in your app there are times when the app is not idle for a long time. And Espresso has some sane defaults for timeouts for such situations. But if you find that your app is not idle for a really long time and it's actually working as intended, then you might have to adjust the idling policies. So there's an API for that. If you have something that's running for a really long time and you still want the test to run, then you might have to adjust that. Pretty much testing basics, but focus on testing behavior, not layout properties. And still, a lot of developers are trying to use Espresso to test like the pixel perfectness of their layouts. And while it's technically possible, it will make your tests really unmaintainable. So if you're trying to assert that a certain view is displayed position X and Y in pixels, and then you work with different screen sizes and so on, and then your designer comes and tells you move that to the right, you have to redo all your tests. So please don't do that. But at the same time, if you really want to assert that, if you really want to check that a certain view is displayed somewhere on the screen relative to another view, we do provide position assertions. But they're relative. They're easier to maintain. If you just need to make sure that a button is next to a text view or below it, then you can use the position assertions. Write many small tests instead of large ones. And to explain this, I like to think about the whole app development process. As you start with working on single screens, on single features of your app, you start writing tests for those single contained pieces of your app, right? A single screen, a single feature then. And these things during development change a lot. So you will go and redo your tests sometimes and just make everything work together. But then as your app gets bigger, more mature, stabilizes, as you're close to release, things are probably not going to change that much. You're going to fix small details, but the overall flow of the app will not change. And that's when you might start adding longer user flow tests. But just don't overdo it. Again, the real value is in the small tests that test every screen, every state of your app. And on the same page, launch directly into desired screen states. So again, when testing these, these self-contained screens and states, launch directly into them. Don't do deep navigation before. If you want to test an activity that's not the first activity in your app, and you need to traverse 5 different screens to get there, something can just break along the way. And then you're not retesting the thing you want to test. You're getting errors about something totally different, totally in another part of your code. So don't do deep navigation. There's ways you can easily achieve that. So if you just override the activity test rule, you can override the getActivity intent method. Just provide a custom intent. If you have an activity that gets some kind of data and then displays a different state, you can just provide that data in the intent. Just remember, if you use this, every test in your class will have the activity started this way. If you need some more custom fine-grained control, just use the 3-argument constructor. And if you pass false as the last argument, the activity will not be launched automatically for your tests. And then in every test, you can just prepare the intent that you want, and just remember you have to launch the activity manually. Most UI tests should be as hermetic as possible. So again, you want to test your app. You want to test the screen of your app. You don't want to test the network conditions. You don't want to test if the server is working. You're testing the features that you're counting inside your app and in your UI. So make your tests as hermetic as possible. There's tools that can help you with that. There's Espresso intents. There's Mockito for mocking. Remember about dependency injection and Dagger 2. And basically, just make sure you're isolated from all the layers that you don't care about, because that's not really UI testing then, is it? And speaking of Espresso intents, I don't know if you've used it before. It's a really nice thing that we've added to Espresso. It's a very small API. Basically, it lets you verify intents that are sent from your app or stop the responses to intents that you send to other applications. So here in this screen, you can see in before, I'm setting up response stubbing for an intent that I sent out to the camera app. And below at the bottom, I'm just verifying that when I click the button, my app sends out the intent. I encourage you to use it to isolate your tests from external applications. Learn how to handle long-running animations. That's been a common and problem in Espresso. We try to synchronize on a lot of things, like I said, on async tasks and so on. But sometimes, Espresso just simply can't run because something keeps animating in your UI. And there's two types of animations I want to call out specifically. On the left, you can see, oh, it's not animating. That's curious. Oh, it's animating now. Let's say you have some kind of drawable. It's your own animation. You created it. You control it. It's all up to you if it runs or not. And on the other hand, you have animations that are kind of embedded in the framework, right? So, for example, a progress bar is something you don't really control. It's just a system widget. It animates, and there's not much you can do about it. And there's a way to actually deal with the animations that you control. So for running Espresso anyway, we tell you to disable animations in the system. So system-wide, we disable all the layout animations, transitions, and so on. And you can actually leverage that setting and read it in your application's code and decide if the animations are disabled, maybe I should also disable my own animations, because really that's what the user said when they adjusted the setting, right? So it's the right thing to do anyway. And on the other hand, like I said, some things like the progress bar are not very easy to work with. So you will just have to find other ways, like maybe having a separate flavor for your tests when the drawable for that progress bar is just not animated. There's some tools that can help. So for example, in developer tools, you can switch a setting called show surface updates. This might help you identify some of those animations that you were not aware of, but are somewhere in your UI, and keep posting events that keep Espresso from running. And next, how to handle test failures. So your tests will fail sometimes, and it's obviously not intended, but maybe the test is wrong. Maybe you need to write it in some other way. So the good thing is Espresso aims to tell you exactly what went wrong in the test and how to fix it. So we have really descriptive error messages. We provide a message that tells you what went wrong, and moreover, we provide a dump of the view hierarchy so you can look at the exact views and their properties and maybe find the culprit. But if that's not enough, it's very easy to implement your own failure handler. You can, attach your own handler and just log out more data. If you have some information that you think would be useful, you can just add it to the log. One very interesting use of that I've seen online is someone said that Espresso was actually giving him too much data about the view hierarchy for a very, very complex screen. And so he created a failure handler that actually made the logs smaller to only concentrate on the parts that they care about. It's an interesting use. And then there's more developer tools that can help you with debugging. So you can enable showing touches, pointer location, layout bounds. It all basically lets you inspect better what's happening on the screen when Espresso runs. And also use the hierarchy viewer if you just want to interactively explore the hierarchy to, for example, find out the IDs of views or their relative positions in the view hierarchy. There's one more setting, not in developer tools, but in accessibility. So on some devices, they're really slow, or some emulators, especially the older ones. Single taps are not registered correctly. I mean, single taps coming from Espresso. I don't want to go into details, but we really try to hide away the complexity of actually simulating a tap in Espresso. But every tap is actually 2 actions, right? Down and up. And if a device is really slow, if it's bogged down by some kind of background operations or the system is just not keeping up, these 2 operations can happen too far apart, and then the system thinks it's a long press. So basically, if you change the delay too long, that might help the situation. And finally, enable testing for accessibility issues. So that's something many developers still don't think about, sadly, but really, you want to make sure that your applications are accessible to all people who want to use them. And Espresso gives you a very easy way. Just enable the accessibility validator. It's a very easy way to start testing for very common accessibility issues. So please enable that and fix your apps, fix your views to make sure the app can be used by anyone. And what's next? I really encourage you to look at the Espresso documentation. There's a section called Advanced Espresso or Advanced Samples, something like that. And you will see lots and lots of more tips and tricks on how to use Espresso, how to use the more unknown APIs of Espresso. Do check out the Android Testing Code Lab. It's not only about Espresso, it's also about how to structure your app to be more testable. It gives a great overview of all the testing offerings that we have. Finally, we have great testing samples. We have a testing blueprint. And like I said before, remember that Espresso is open source. So if you find any place where it's not working the best it could, if we're missing some kind of matchers, if there's a source of flakiness for your test that we were not aware of, file bugs, or better yet, file pull requests and help us make it even better.